All right, Math 2. As promised, we are now going to go over the sine and the cosine ratios. We've already done tangent. So make sure your name and your period is on your paper. Let's look and see what we got. Our question today is, why are the sine and cosine ratios always less than 1? You're never going to get a sine or cosine ratio that is greater than 1. So think about why that is. So the sine ratio. Now remember, the tangent ratio was opposite leg over the adjacent leg. The sine ratio is the opposite leg over the hypotenuse. Remember, the tangent didn't use the hypotenuse. And the cosine ratio is the adjacent leg over the hypotenuse. All right, so we're going to find the ratios here. So let's look at the sine of A. So here's A. The sine is opposite leg over hypotenuse. So opposite leg is 7, hypotenuse is 25. So this would be 7 over 25. Let's look at the sine of B. Sine of B would be opposite leg over the hypotenuse, 24 over 25. So either way, the 25 was on the bottom because that's the hypotenuse. But when we changed angles, we changed opposite sides. Let's do the cosine of A. Cosine of A is the adjacent leg over the hypotenuse. So here's A. The leg that's adjacent is this 24, and the hypotenuse is 25. So we get 24 over 25. All right. Cosine of B. So here's B. The adjacent leg is 7. The hypotenuse is 25. So we get 7 over 25. Tangent of A. Remember, tangent was opposite over adjacent. So opposite leg is 7. Adjacent is 24. Tangent of B. Opposite over adjacent. So we do opposite, 24, over adjacent, 7. There we go. Now we've got all of our ratios for A, B, and C, or A and B. We've got our sine, cosine, and tangent of A and B. All right, now look really closely at the sine and cosine ratios. The sine of A was 7 over 25. The cosine of A was 24 over 25. The sine of B was 24 over 25. The cosine of B was 7 over 25. See how these are related? The sine of A is the cosine of B. And the sine of B is the cosine of A. Because the opposite and adjacent switch. So we know that the sine of an angle is always going to be the cosine of the complementary angle. Because remember, these two angles have to add up to 90 because we already got 90 there. So they have to add up to 180 total. So if this is 90, these two together make 90. So whatever the sine of an angle is, it's going to be equal to the cosine of the other angle. See, the sine of this one was the cosine of this one. The sine of this one was the cosine of this one. Because the opposite of one of them is the adjacent of the other one. Now in tangents, the tangent of one angle compared to the tangent of the other angle, see how these are reciprocals? They've been flipped over. So the tangent of an angle is the reciprocal of the tangent of the complementary angle. All right, we're going to just jump into solving since we've played around with how to set all these up, especially in the tangent section that we've already done. So let's go ahead and solve these ones. Let's just start with x. So we already said that these are complements to each other. So this is 48. What's the complement to 48? X would have to be 42. So that would be 42 degrees. Okay, so we know that x is 42 because it's complements with the other acute angle inside of the triangle. Let's solve for a now. In order to solve for a, we get to choose what we want to do. Now here I've got the 48 degree angle and I've got the 42 degree angle. And then I've got this side here, 10. So I have to use the 10 because I have to have at least one side to work these out. So what I'm going to do is, let's start with this angle, and I'm going to do tangent because tangent does opposite over adjacent. So to solve for a, I'm going to do the tangent of 48 degrees is equal to a over 10. Okay, so I've set up a trig function. I got the angle, and then it's opposite over adjacent. So here I can multiply both sides by 10. And I get that a should be 10 times the tangent of 48. And then you just need to plug in your calculator at this point. So depending on your calculator, we can do 10 times tangent 48. So that's this type of calculator. All you have to do is type in that, and you get approximately 11.1. Remember, you've also got your phone calculators that I'm sure a lot of you are probably using. Remember, you have to type these in backwards on your phone calculator. So you'd have to do 48 tangent times 10. And you still get 11.1. Okay, it's just backwards when you type it in. All right, now we can do B. B is the hypotenuse. So I can't do tangent because tangent doesn't use the hypotenuse. So I'm going to have to use something else. Let's go ahead and use the 48 degree angle. I've got the adjacent and hypotenuse. So which uses adjacent and hypotenuse? Cosine does. So this must be a cosine problem because I've got adjacent and hypotenuse. So I'm going to say cosine of 48 equals adjacent is 10, hypotenuse is b. Okay, remember what we did? We multiplied by b, then divided by 48. There's another thing that you can do kind of as a shortcut. You can just switch. Anytime that you've got a proportion, you can, it's called exchanging the extremes, or is it the means? I can't remember which one. Anyways, you're allowed to just switch these two. They would be equivalent to each other. So I'm going to put the b up here and the cosine 48 down there. So b is equal to 10 divided by the cosine of 48. We already proved in the last lesson that that kind of works. So let's clear that out. I'm going to do 10 divided by the cosine of 48. And we get up 14.9 about. So B would be about 14.9. All right, so if you're doing it on the other type of calculator, remember, you kind of have to go backwards. You go 10 divided by, one of my family members is texting me. All right, 10 divided by 48 cosine. 48 cosine, that's not the answer. That's what 48 cosine is. Now you have to hit equals. And you still get 14.9. A lot of people forget the hitting of the equal at the end there. That's probably where you're messing up if you mess up. All right. Last one. Without a calculator. Ooh. Ooh. Find out what the sine of 30 is. What? Sine of 30? How do I find the sine of 30 without a calculator? It's a 30, 60, 90 triangle. Wait a second. I did something with these. 30, 60, 90. Remember that? That was the b root 3, and 2b. So let's find the sine of 30 degrees. Okay. So the sine of 30, remember, sine is opposite over hypotenuse. So the opposite is b, the hypotenuse is 2b. So b over 2b. Well, this is like having 1b right there, right? Well, I got b over b. That means I can reduce the b's. So the sine of 30 is always going to be 1/2. That's the scale factor. And we already know that. The scale factor of the smallest leg is the hypotenuse. The hypotenuse was twice as big. So 1 over 2. Okay, let's look at the cosine of 30. Cosine of 30 should be the adjacent over the hypotenuse. The adjacent leg is b root 3. And the hypotenuse is 2b. Again, I can reduce the b on top and the b on the bottom, and I end up with root 3 over 2. Or we can say that's half of root 3. The cosine of 30, no matter what you put in on the sides, will always be half of root 3. The sine of 30, no matter what you have, is always going to be 1/2. Because remember, these are similar triangles. If this were 2, this would be 4. And 2 over 4 is 1/2. If this were 6, this would be 12. And 6 over 12 is 1/2. Because they are similar triangles. That's why this sine, cosine, and tangent all works. Is because they are all similar triangles. And this is the scale factor. The end. That was a nice story, wasn't it? All right, math hard. See you guys later. Bye-bye.